Hi everyone! Today we're talking about the triangle inequality theorem, which talks about what side lengths will create a triangle. In fact, it actually states that the sum of any two side lengths, so sum is when we add them together, must be greater than, the length of the third side. So add two side lengths together, that length must be larger than whatever the third side length is. So to show that, to demonstrate that, I have 4 different lengths of straws, and we're going to see what combination of these straws will create triangles and see if they match this inequality theorem. I'm actually going to just start with 3 of the same lengths, and I'm going to see if they're going to make a triangle. So, okay. All right. So automatically, I do see that will create a triangle. I'm going to flatten them. I'm going to collapse them to see if they match that triangle inequality theorem. So I'm going to take 2 side lengths and I'm going to add them together. I'm going to put them together. And then I'm going to take the third side length and I'm going to compare it to that length. Whoa. Yeah, that's definitely the sum. Putting those 2 lengths together is definitely larger than that third length. So that matches with the triangle inequality theorem. Now maybe I just use a green. Let's do a pink and a yellow. Okay, see if I could get that to make a triangle. Oh, okay, I got a triangle. Now I'm going to collapse it and do the same thing. I'm going to add the green and pink together. I'm going to compare it to the third side length. And in fact, it's not much bigger, but we do see that the sum of those 2 lengths is in fact larger than our third length. 2 pinks and an orange. Now I'm going to try and get these, man. Okay, so obviously these aren't making a triangle. Now I'm going to compare them. I'm going to add the 2 pinks together and compare it to the orange. Okay, so as we see here, this did not match that triangle inequality theorem because those pinks are not larger than the orange. So that's why it didn't make the triangle. Let's do a green, a pink, and an orange. See if that works. Okay. Man, we're getting closer to triangle, but I'm not really able to like make a triangle. So again, when we collapse, we see that the green and the pink together are still shorter than that orange side. Maybe I do an orange, a yellow, and a pink. Man, I'm getting real close, but I just can't. So when I flatten it, we see that the length of the pink and the length of the yellow are exactly the same length as the orange. Now, this, when our lengths are equal to each other, that's a special case, okay? That is called a degenerate triangle or a flat triangle. Now, in some math classes, that is a special case, and it is actually included in the triangle inequality theorem. However, we, in our class, we are not going to include this possibility because it'll just make things easier. We only want lengths larger, okay? Not exactly, not smaller, okay, like we saw here. We don't want smaller, and we don't want the same. Don't want that. However, we do want our lengths to be larger, okay? So smaller is a no-go. Don't want that. Exactly the same as a no-go. Don't want that. Larger. We want those 2 lengths to be larger than the third. All right, that's all I have for you guys. I hope y'all have a great day. Bye-bye.